My hypothesis for my project was that ocean acidification would lead to a decrease in mussel shell formation due to aragonite, which is the main component, and a form of calcium carbonate being dissolved in more acidic water. This hypothesis was not supported by my data, so I rejected it. These graphs show the ratio of average growth of mussel shells in elevated acidity conditions over the average saturation of aragonite in elevated acidity conditions. And then the same thing for the control group, but in control conditions, which were normal acidity or low PCO2, and then high PCO2 is the high acidity. And I performed a t-test on these ratios, and that led to a high p-value of 0.596, which means that the groups were not significantly different. And this research matters because since the Industrial Revolution, the ocean has become more acidic at a faster rate, and ocean life that adapted over millions of years may not be able to adapt fast enough to the changing ocean. And I pulled my data from two sources. From the first source, I got the mussel shell growth in millimeters in the high acidity and low concidity conditions, which were 380 microatmospheres PCO2 and 750 microatmospheres PCO2. And then from the second source, I took the aragonite concentration, which was the concentration of the calcium ions and carbonate ions over the concentration of calcium carbonate. And that was also from the control groups, which were 400 microatmospheres and 700 microatmospheres of PCO2. And then combining these data sources, I calculated the ratios on the slides that I showed before. I performed a t-test to see if the means were significantly different, which they weren't.